In this session, we'll be seeing about the financial function NPV and IRR. NPV is net present value and IRR the internal. These are the various functions that we'll be working. NPV, we call it as net present value, is one of the method of capital budgeting process. So capital budgeting we mean it's a planning of capital assets. It is like taking a decision whether to invest the money in long-term project or whether not to invest the money in long-term project. So ultimately it entirely takes about taking the decisions that we have to make. Normally the long-term projects could be installing a machinery in your factory or keeping with the decision of making the product or buying a product or a process. So net present value and the internal rate of return are the most commonly used financial analysis function. So in this chart, you can see that the project acceptance rate and the rejection rate. So machining work, there may be a heavy machinery may be involved in machining operations. Maybe the project decisions that they would have taken is like the acceptance rate was 4.3%, right? And in the cleaning department, they have the cleaning machines where the decision was pending. Maybe the NPV will be generating a value of 0, or maybe it may be giving a high positive returns, or it may be giving a negative returns. Decisions may be pending. And in case of the inventory, where we have to stack the whatever the products in the rows, right, with the help of the forklift. So maybe the decision on buying a forklift may be where you'll be using the NPV. So in this case, they have the 3.5% of acceptance rate. Similar way, if you go for the churning process, right, where we have the churning process with the chemical reactants, for that they have the 5% rejection rate, where they may be having the plan that the investing in such project is useless, or investing for buying such machines could be useless, right? So these are the decisions that normally can be done with the help of this tool. So we should know something on the interpreting of the NPV. So when we talk about cash inflows, it should give you the positive values, and when we talk about the cash outflows, it is negative values. So these are the decisions that we have to take. So what does NPV function does in Excel? This function returns the sum of series of cash flows, discounting it today or the present day, right, using a single discount rate. So this is your single discount rate. So we have to look at the syntax when we'll be getting into the Excel. So here the NPV is 0, the discount rate. So discount rate, it is a rate where the future cash flows has to be discounted, or in simple I can say the rate of return that then investor is requires, right? This is the rate of return that an investor. In a similar way, when we talk about the NPV returns 0, what does it mean actually? It means that the discount rate which was mentioned will exactly equals the rate of return which provided by the future cash flows, right? Then suppose NPV is the positive and we are getting the positive result, NPV is positive, it means that the future cash flows provide a better rate of return than the discount rate which has been specified, right? Then suppose you get the result as NPV as negative. In this case, you can find that the future cash flow has not provided better return. So this seems the interpretation of doing an NPV. In Excel financial functions, we'll be using the two functions. One is for regular cash flows. If you are having a regular cash flows, then you have to use the function NPV, the IRR and MIRR, right? And in case you have the irregular cash flows maybe for first month, say in the January month, on the in the January month itself you're getting the cash flows, right? Say on 15th of January you're getting a cash flow, and once again you're getting on 20th of January, then you're not getting any cash flow. In next month, say on February you're getting only on 15th, and March month you're not getting any cash flow, and again in April you're not getting any cash flow, and in month of May 15th you're getting the cash flow. So that we call it as irregular cash flow. In that case, you have to use this adding the prefix called X to NPV, right? X NPV and X IRR, right? So we'll be working with the two case problems. The case situation 1 where we'll be calculating the NPV. Suppose a firm invests rupees 10,000 in a project with a life of 3 years. The project cash inflows, these are the project cash inflows they have given, and the cost of capital is nothing but the minimum rate of return, or we call it as discount rate, which has been given, and we'll be finding whether the NPV comes out with negative value or positive value. Normally in manual calculations, normally we put the cash inflows in first table column, then we calculate the present value interest factor for this 10%, then we multiply the present value interest factor with the cash flow. Then when we add the entire cash flow while multiplied with your present value interest factor, then when we add, we'll be getting the value of NPV. So this can be easily done in case of the Excel functions. Let us get into the Excel part. So we'll be working this with the help of the Excel function called NPV. So getting into the Excel, the cost of capital that they have given is 10%, right? The investment that they have made is 10,000 for the project, 10,000 for the project, right? So first is the cash outflow, which is, we should put it in the negative value. So I'll be putting it within the parenthesis. So I'll be typing 10,000. So automatically it comes the negative value of 10,000. Then we have to enter the cash inflows, right? So first year cash inflow is 4,000. So second year cash flow is 5,000, and third year cash flow is 4,000. So for this, we have to directly calculate the NPV. So instead of calculating the present value interest factor for the 10%, the minimum rate of return, then multiplying it, it will become a lot of time, right? Instead of that, you can use the Excel function. So equal to, I type NPV. So here it tells that returns the net present value of investment based on a discount rate and a series of future payments, negative values, and income positive values, right? So negative values, this is your investment, which is your negative values, and income is your positive values. So close the open the parenthesis, then we have to input the rate. The rate is 10%, comma. So here you have to select only the cash inflow. So I'll be selecting the cash inflow, which is in the cell from F8 to F and F10. So shift down arrow, then close the bracket, then minus, then you have to do the investment, which is 10,000, right? So 10,000 is the investment. So I'll be selecting this cell called I3, then I enter. It gives you in percentage, right? So there is a format change, so we can do the format change over here. So go here and put it in currency. So now you get the NPV value, which is the positive NPV value. So it means that we can accept the project, right? So the it is better that you can invest rupees 10,000. It is better that you go for the project because it gives you the positive NPV. Coming to the case situation 2. Here a company has 2 projects and it has to select one project. So the cost of project X is been given, which is 11,000, and the project Y they have given is 10,000. And the cash inflows for project X is given, that is 6,000 for first year, 2,000 for second year, 1,000 for third year, 5,000 for fourth year. In similar way, the project Y cash inflows is given, which is 1,000 for first year, 1,000 for second year, 2,000 for third year, and 10,000 for fourth year. Now you have to find what is the internal rate of return of the above 2 projects. So we have to calculate what is the internal rate of return of project X and internal rate of return for the project Y. So let us get into Excel. So let us feed the values into project X and project Y. So project X at the 0th period, which is nothing but the investment that has been made into project X, which is 11,000. So I put it in the bracket 11,000. Then I put the investment made in project Y is 10,000. I put it in the bracket because it is a cash outflow. Then simultaneously I'll be feeding the values of the cash inflows. So 6,000 for first year, 2,000 for second year, 1,000 for third year, 5,000 for fourth year. In similar way for project Y, 1,000 for first year, 1,000 for second year, 2,000 is the cash inflow for third year, and 10,000 is the cash inflow for fourth year. Now we have to determine what is the rate of return. So investment has been given but we have to find the rate of what is the internal rate of return. So we can directly go to the function equal to IRR. So it gives what it says, it returns the internal rate of return for a series of cash flows. So when I press the tab key, you have the argument, the syntax, which gives you the first it asks for you the values, then it asks for the guess, right? So values, we have to select the values from all the values we can select, right? So I'll be selecting the values, all the values from F19 to F23. So I've selected the value. Then it will be asking for the guess. So guess is nothing but it's what is the value that you have to feed into it. So normally you can put minus 90%, right? Or you can type 0. So it's like it's an iteration process, right? So nothing to worry about that. You just put 0 or minus 90%, the value will same. So I put a 0 over here and I close the bracket because it gives you the approximate return, right? So I press enter here. So I'll be getting the project X gives the return is 11%, right? In similar way, equal to IRR, then it will be asking for the values. Also, I'll be selecting all the values from G19 to G23. So G19 to G23, then comma, you press 0, then shift, close the bracket and enter. So you find that the project Y gives you the internal rate of return is 10%. So in this case, selecting a project requires which project gives you the higher return. In this case, 11% is the higher return, which is given by project X. So that is the selection that you have to go for choosing the project X. So that is a decision that you will be taking, right? So this is an approximate value.